Let's start with the problem that we already know how to do. An unfair coin is flipped 3 times, and we know the probability of getting heads is 1/5, which means the probability of getting a tails is 4/5. Let's find the probability of getting exactly 2 heads. Alright, so we can just draw a tree for this, and there's going to be 3 stages because we flipped the coin 3 times. So on the first stage, heads or tails. Similarly on the second stage. And finally there's a third stage. And the probabilities that we can fill in, those aren't too bad either, because all of the H's have probability 1/5, so all of the T's have probability 4/5. Okay, now we can write down our outcomes. There are 8 of them, as we can see here. And now we can write down the probabilities. We just have to multiply across. So that's the first one. The second one is 1/5 times 1/5 times 4/5. The third one is 1/5 times 4/5 times 1/5. And the fourth one is 1/5 times 4/5 times 4/5. And we can do the same thing as we fill in these. Alright, so we filled in the whole tree, and now the question is, what's the probability that we get exactly 2 heads? So let's just look at our outcomes and then add up their probabilities like normal. So exactly 2 heads looks to me like that one, and that one, and that. Those 3. Okay, so then we can write that the probability of exactly 2 heads is, well, let's just see what we have there. So the first one is 1/5 times 1/5 times 4/5. The second one is 1/5 times 4/5 times 1/5. And the third one is 4/5 times 1/5 times 1/5. I want you to notice something about these numbers though. So those 3 numbers that we added together, those 3 probabilities that we added together, they're all exactly the same. If you multiply them, you get 4 in the numerator and 125 in the denominator. They're all 4 over 125. And in the next video, we'll see why that happens and see if we can actually get these probabilities without drawing a big tree.